Hi, my name is Hui Yang, and my project for pattern recognition is machine comprehension. Machine comprehension evaluates the understanding of the system through a series of questions in a short test to answer the task so that the correct answer can only be found in a given paragraph. The task of machine comprehension has attracted more and more interest in industry and academia in recent years within NLP communities. So I use the dataset called SQUAD in my project, and it stands for Stanford Question Answering Dataset. It's a reading comprehension dataset consisting of questions posted by crowd workers on a set of Wikipedia articles where the answer to every question is a segment of text or span from the corresponding reading passage, or the question might be unanswerable. The previous version of SQUAD is called SQUAD 1.1. This version contains more than 100,000 questions and answer pairs, and is from more than 500 articles. The latest version of SQUAD is called SQUAD 2.0. Compared to SQUAD 1.1, it adds 15,000 new unanswerable questions written by crowd workers to look similar to answerable ones. So in my project, I use SQUAD 1.1. There are basically two very important models in my project. One is called BIDEF, and one is called BERT. So attention is basically the foundation of BIDEF. So let me introduce attention first. Attention is a mechanism for improving the performance in the RNN-based encoder and decoder model, commonly referred to as the attention mechanism. As attention mechanism is really popular in recent years, it has been widely used in many fields such as machine translation, speech recognition, image caption, and so on. It is so popular because attention gives the model the ability to distinguish between regions. Each word in a sentence is given different weights, making the learning of the neural network model more flexible. And attention in itself can be used as an alignment relationship to interpret the translation between the input and output sentences. The alignment relationship explaining what the model has learned provides a window for us to open the black box for deep learning. And you can see the architecture of attention mechanism on the right of the slides. The attention mechanism has made machine reading comprehension and question answering have achieved good results in many tasks in past few years, but in previous paper, the use of machine comprehension, you should have the following main characters. The first is use the attention mechanism to summarize the context to a fixed size expression. And the second is when calculating attention, that is often related in time series. The calculation of current time attention depends on the result of attention at the last moment. And the third is the calculation of attention is usually one way. Usually query attends on the context paragraph of the image. So here comes to BIDEF, and its full name is bidirectional attention flow model. BIDEF is a model that works on calculating the attention of context to query and query to context at the same time. The calculation of attention is independent in timing and will follow the next layer, avoiding the loss of information caused by premature summary. The machine comprehension model in my project is a hierarchical multi-stage process and has 6 layers. The layers are character embedding layer, word embedding layer, contextual embedding layer, attention flow layer, modeling layer, and output layer. And you can see the 6 layers on the left of the slide. Then there's their architecture. So there are basically 3 characters about BIDEF. which is different from the traditional attention. The first is that it does not encode the context into a fixed size carrier, but allows the vector to flow, reducing the loss of elevated information. The second is there's no memory. At each moment, only the query and the context segment of the current moment are calculated. It does not directly depend on the attention of the previous moment, which makes the sequence attention calculation not affected by the previously run attention information. And the third character is the attention information in both the query context and the context query is calculated. And it is considered that C to Q and Q to C can actually complement each other. The experiment found that the model removed C to Q on the development set and decreased by 12 and 10% points compared with the removal of Q to C. Obviously, the concern in the direction of C to Q is more important. So, now I'll introduce the 6 layers of BiDAF model. I write 5 layers in my paper. So I combine the first 2 layers in input embedding layer. So input embedding layer is actually the combination of character embedding layer and word embedding layer. For the context paragraph in the query, each word is mapped to a high-dimensional vector space using the character level CNN. By pre-training word vector, auto vocabulary and character vector can be trained. Word vector is trained by CNN. The representation of the word is obtained by splitting the word vector and the character vector and then obtained through the 2-layer highway network and obtains the context vector X and the query vector Q. The second layer is called embedding encoded layer. Embedding encoded layer is actually equals to contextual embedding layer. We use the by LSTM to encode the results of the previous step, Q and X respectively, capturing the local relationship between the X and Q words, and splitting the output of the bidirectional LSTM to obtain H and U. The first 2 layers are used to capture the different characteristics of the query and the context. And the third layer is called the context query attention layer. This layer is equals to attention flow layer. The input is H and U, and output is the query vector G of the context word. And the contextual embedding passed down from the previous layer. Do context to query and query to context attention in both directions. The procedure is the same. First, calculate correlation matrix, then normalize the calculation of the attention results, and finally multiply the original matrix to get a modified vector matrix C to Q and Q to C, shared similarity matrix S. And here's the equations and below. This layer contains 2 really important parts. The first is called Q to C, query to context attention. The layer aims to calculate which contested word are the most relevant to each query word. Take the maximum value of each column of the matrix. Use a softmax normalization calculation on the context vector weighted sum, and then tilde t times to get H. And here's some equations about calculation. And the second important part of this layer is called context to query attention. There's no compute the most related query words to every context word, as the matrix obtained earlier. Now we use softmax normalizes the column and then computes the query vector weighted sum to get U. The fourth layer is called model encoder layer. The input is matrix G. After being by LSTM, we can get M belongs M from dimension 2D by T, capture interaction among the context-ordered condition and the query. Each column vector of M contains text information about the entire context and query for the corresponding word. The fifth layer is called output layer, predicting the start position P1 and the end position P2, and both P1 and P2 is being softmaxed. And then M used by LSTM to get M squared, which is used to obtain the probability distribution of the end position. So here comes to my code to achieve BiDAF model. The first, you can see from the first picture that I replaced the word embedding layer with BERT language model. And the second picture, I concurrent the character and word embedding together and pass them into the highway network. And the third picture, I passed the output of the last step into the contextual embedding layer, which is RNN layer. And fourth, I passed the representation of the context and query into the attention flow layer and obtain the query over context representation. And the last, I use pointer network to point out the answer position in the paragraph. So here's the training BiDAF process and results. You can see that I used 12 epochs and the final result is the max EM is 64.494 and the max F1 is 75.676. So here comes BERT. BERT is also, like I introduced before, BERT is also a very important part of my model. It's a new language representation model, which stands for bidirectional encoder representations from transformers. BERT pre-trains the bidirectional layers by capturing the forward and backward semantic and lexical expressions. Then the pre-trained BERT model can be fine-tuned for downstream tasks without need for substantial task-specific architectural changes. So the embeddings of BiDAF is actually the combination of three embeddings, and they are token embeddings, segment embeddings, and position embeddings. You can see from this picture, it's very clear. And I used a packet online called PyTorch pre-trained BERT, and I trained the Scott dataset. Here are some configuration I used. And this is the code to achieve BERT. I first read dataset and then make each sentence as a line and make a vocabulary with 4 special tokens used for training with preprocessed point pi. You can see from the first picture, and the second picture is about how to train the BERT model. You can see it has the backward optimizer step. So here's the conclusion. In this project, I present BERT on BiDAF, a multiple stage hierarchical process that represents the context at a different level of detail. Using a bidirectional attention mechanism to get a query-oriented context representation without an early summary, the model achieves good results on Stanford question answering dataset. And this model can learn the right representation for the MC, machine comprehension, and is able to answer complex questions dealing with the correct locations in a given paragraph. So that's my presentation. Thank you for listening.